Welcome to 1.1 Linear Functions Part 2. Today we're going to talk about vertical stretches and shrinks. The graph and graphing and describing stretches and shrinks. So when we're talking about vertical stretches and shrinks, we're talking about vertically stretching it out or shrinking it up. Okay, so visualize on your iPad if you're fixing a picture, and don't change the width of it, but you physically make it taller. What's going to happen to your picture? So a vertical stretch will make it tall and skinny. If you were to shrink it down vertically but leave the width the same, the picture would get short and fat. So that is a vertical shrink. So same idea with graphs. Graph each function and its parent function, then describe the transformation. So let's look at A. The parent function here is f of x equals the absolute value of x. We know what that graph looks like, but if you forgot, you can always do a t-chart. So f of x, and there's x, and I always like to pick the points -2, -1, 0, 1, and 2. I'm going to take the absolute value of those, such as 2, 1, 0, 1, and 2. Okay, I can do that in my head. Just the absolute value of -2 is 2. The absolute value of -1 is 1, and so on and so on. So we'll graph these. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. So you notice the slope on the right-hand side is +1, and the slope on the left-hand side is -1. This is the absolute value parent function, and we're going to call this one f of x. So let's graph g of x. And if you have no idea how to graph this, we always can rely on t-charts. So let's do f or x and then g of x. So we're going to take the absolute value of those and then times it by 2. Okay, so let's look at our little think cloud down here. We'll do some math. So if I plug in -2, the absolute value of -2 is 2. 2 times 2 is 4. If I plug in a 1, if I plug in a 1, 2 times the absolute value of 1, the absolute value of 1 is 1. 2 times 1 is 2. 0, 0, 1 is going to be 2, and 2 is going to be 4. So let's graph those. So we got the point -2, +4, -1, 2, 0, 0, 1, 2, 2, 4. Those are nice straight lines. And we're going to label, that's g of x. So you notice that the blue function, which are g of x, is more narrow. So if you think about stretching this vertically, it becomes like skinnier, taller, narrower, okay? So we're going to graph each function and then and its parent function and describe the transformation. So this is a vertical stretch. Let's look at part B. So let's graph the parent function. The parent function here is, we'll call it m of x. I'll just give it a name. Doesn't matter what it is. So m of x equals x squared. So that's going to be our parent function. It is a quadratic. So let's do a t-chart if you're not sure what that looks like. So x, m of x. So this is, the red is going to be the parent function. I'm going to use the same points, -2, -1, 0, 1, and 2. And notice that I'm just squaring my x values. That's all you have to do. So I'm going to come down here. I'm going to square each one of these. So -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Let's graph that one. So -2 positive 4, negative 1, 1, 0, 0, 1, 1, 2, 4. Now you notice that this isn't quite a V. It kind of looks like a V, but it's not. This is U-shaped. These are called, the shape's called a parabola, okay? But it's a quadratic function. So this is m of x. So it's nice and U-shaped, it's pointing up. Now let's take a look at the h of x. So h of x, let's mess that up. So x, h of x, plugging negative 2, negative 1, 0, 1, and 2 again. Again, I just like those numbers. There's no reason you couldn't pick other numbers, but it's nice and symmetric. And what this is doing, if you look up here, look at the, we're going to take x squared, and then we're going to take half of that. So we can, since we're picking the same x values, this is already x squared, so I can just take half of that, okay? Or you can do the math again in your head. It's really up to you, okay? So negative 2 squared is 4, half of 4 is 2. Negative 1 squared is 1, half of 1 is 1/2, so it's 0.5. And since we're graphing, decimals are probably better. 0 squared is 0, 0 times 1/2 is 0. 1 squared is 1, half of 1 is 0.5. 2 squared is 4, half of 4 is 2. So let's graph these. So negative 2, 2, negative 1, 1/2, 0, 0, 1, 1/2, 2, 2. All right, so this is, notice that this parabola is a little bit wider, okay? It's a little bit wider. So if like we visually like push down on it, make it a vertical shrink, it will actually become wider. So we're gonna call this one a vertical shrink. And a cool thing that you can look at, if that number out front is bigger than 1, it is a stretch. If it's between 0 and 1, so some kind of decimal that's less than 1 but bigger than 0, it is a shrink. Sometimes there's several transformations going on at once. So we're going to rely a lot on our graphing calculator, also on our geometry skills. I pulled Desmos up for our graphing calculator. You can go to www.desmos.com/calculator and get to a graphing calculator online, or you could download the app. It'd be nice if you had the app because it's very useful, okay? So let's graph this. Now let's talk about the parent function, okay? We notice we have absolute values, so the parent function is the absolute value function. So this is an absolute value. And we'll call it f of x. So f of x equals the absolute value of x. We need both of them so we can look at both of them before and afterwards. So let's graph our parent function first. So in the first box, we're going to graph y equals the absolute value. Notice your absolute values down there on the left-hand side. And we're going to type in x and finish it off with another absolute value. So that is our parent function. So let's graph the g of x. So we're going to graph y equals negative absolute value of x plus 5 minus 3. We can't quite see the whole thing, so we can move our graph around so we can definitely tell, okay? So we need to describe the transformation. So we want to look at this. So we got to do a couple things. So make sure, use your geometry skills, visualize moving this graph and mapping it on top of itself, okay? So the first thing I want to do is I want to move the red function, which is our parent function, over 5 units to the left. So 5 units to the left. And then, so now we have something that looks like this. Okay, then I want to flip it upside down. So then I want to want to reflect over the x-axis. So now that graph looks like, so I'm going to erase this part. I'm going to flip it upside down, so now it looks like this. So that's the reflection. For the last thing, I'm going to move it down 3 units. So that is the transformations that are occurring to map the parent function onto my new function. Make sure you slowly follow your directions, okay? Because order does matter, all right? If I moved it 3 units down and then flipped it, my graph would actually be above the x-axis and it wouldn't map on top itself. So you gotta be very careful. So visualize each movement, do one at a time, and then make your way down to your new function. So let's look at example 6. The table shows the height of y of a dirt bike with x seconds after jumping off a ramp. What type of function can you use to model the data? Estimate the height after 1.75 seconds. Okay, so we have some points. So let's graph those, okay? At 0, it is 8 units high, so 0, 8. 1/2, 0.5 is up to 20. 1 is up to 24. 1 and 1/2 is up to 20. And 2 is up to 8. Now looking at it, it is very U-shaped. It looks like a parabola. So let's sketch a nice, even quadratic equation on top of there. Nice. The parabola is the shape. It's the U-shaped. Okay. So we're going to call this, what type of function can you use to model the data? Well, we can use a quadratic. You don't have to find the function yet. We'll do that later on this year. But we just know it's a quadratic function. And they're asking us to estimate the height after 1.75 seconds. So 1.75 is about here. So let's trace our way up and over. So it looks like it's about, what's that, 14? So about 14 seconds, not seconds, sorry. About 14 feet. And that is the end of lesson 1.1 and the second part.